Hey folks, today we're going to be talking about this thing called dimensional analysis. That's the technical name for it. I'm going to call them conversions, but just know if you see the phrase DA or the letters DA, it's dimensional analysis conversions. It means the same thing. What we're talking about here is stuff like this. How many quarters are in a dollar? How many inches are in a foot? How many feet are in a yard? How many seconds are in a minute? That sort of thing, where for example, you have 4 quarters for every dollar or 12 inches for every foot. Um, so if I were to give you a problem, one of the basic dimensional analysis problems is something like you have 3 feet. How many yards are in 3 feet? And you would say, well, I have 3 feet. That would be 1 yard, right? Because 3 divided by 3 equals 1. That's pretty basic math. What we're going to do, though, that's going to be a little bit tricky is not every conversion will just be one step. And the other thing we're going to do today is we're going to show you how to actually put those steps in proper, like, scientific form so that once we start getting into other types of conversions that we do in science, you'll kind of know how to set them up. So just so you know, what we're going to start with today is very, very basic, but what we'll build up to is complex. However, even though what we're building up to is complex, the same format that we'll teach today will apply. So it's not necessarily important to be able to correctly do the math, but it's more important to see the pattern on how to set up and the format. And this will make more sense as we talk about it. So question for you is, why do we call a quarter a quarter? And that's because of this right here, 1/4. We know that for every 4 quarters, we have $1. So it's a fourth or 1/4 of a dollar. Now, this right here, this $1 over 4 quarter, we call this a conversion factor. And a conversion factor is something that we're going to be using in dimensional analysis. So we'll come back to that in a little bit. But for now, here's a little algebra review. Okay, if you have a value, let's say x, and you're multiplying it by the quantity 1 over x, what does that equal? That was a lot of fancy math speak, but hopefully you know that if you take x and you time it by 1 divided by that same number, any number divided by that same number, it's just going to equal 1, right? So if you have a number to the side and then that same number on the bottom, or if you have a number on the top and a number on the bottom, those numbers cancel out. So in this case here, we just end up with the value 1, right? So the important thing to know here is that it cancels. What we're going to do is not necessarily worry about numbers, but we're going to use this with units. So let's say, for example, we have 3,578 quarters. Well, we want to figure out how many dollars we have, so we know that for every 4 quarters, you have $1. Now, if we use this little conversion factor here of $1 divided by 4 quarters, we can actually cancel out quarters here. Well, bam, just like that. And then we end up with, $894.5. So the math we did here is we canceled out quarters, and then we took 3,578 and we divided it by 4. So that's something that's going to be true. We're going to set up units so that the unit on top or the unit to the side cancels out with the same unit below it. And then we're going to set it up so every number on the bottom gets divided and every number on the top gets multiplied. So this math is really 3,578 divided by 4 times 1. But of course, we know any number times or divided by 1 is just the same number. That's like the identity theory in math or whatever. If anything you do to 1, it just kind of stays the same. So we're going to use this a lot with conversions. So let's move on to the next slide here. But yeah, the key here is no matter whether it's a number or if it's a unit, those units are going to cancel out. So in this case, you'll notice that my unit at the end is dollars. And that's true, right? If you were to take, you have about $800 if you've got about 4,000, quarters thereabouts, or 3,500, whatever it is. Okay, now here's what I want to show you. We will be doing conversion factors where there's 1 step, 2 steps, or 3 steps. And I want to show you the biggest of them first, just so you can kind of see like this is as complicated as it's going to get, and then we'll kind of break it down from there. So here we go. What I'll ask you is I'll give you a number and then some unit, we'll call that A. So this could be like grams, it could be like meters, it could be feet, it could be inches, it could be anything. And then you'll have to convert it into some other unit, like maybe if you're going to grams, we'll go to pounds or something like that. You probably don't know the conversion from grams to pounds off the top of your head. And we might not necessarily give you that conversion, but we'll give you a conversion to a conversion to a conversion, if that makes sense. Let me explain. So here in this problem, we're saying 100 feet into meters. Okay, I'm going to show you the general kind of formula, A to D here. And then we'll talk about specifically going from feet to inches, inches to centimeters, and centimeters to meters. Here we go. Here's the general formula. You start with a unit A, and then there's some ratio between A and B. We don't necessarily know what that is. It could be 1 to 2. It could be 3,500 to 4,600. It doesn't really matter, but you would just put those numbers, the number that goes with A next to A, and the number that goes with B next to B. And then we would find a conversion from B to C. Again, there'd be a number for B and there'd be a number for C. And then the same thing, C to D. So in this example of feet to meters, 1 would go next to the red A here. 1 foot would go next to the red A here. And then 12 inches would go next to the blue B here. Then for the next conversion factor, 1 inch equals 2.54 centimeters. 1 inch would go on the bottom here, and 2.54 centimeters would go on the top. Same thing with the third conversion factor. 100 centimeters would go on the bottom with this yellow C, and then 1 meter would go on the top. So here's what that looks like. Just like this. Notice how here in both kind of situations, whatever we have in the previous kind of top part gets canceled out on the bottom part of the next. So for example, A is over here, then A is down below. B is up top here, then B is down below. C is up top here, then C is down below, and then finally D is what we end with, so our answer will be in terms of D. Now, with actual units, what that looks like is we start with feet, cancel out feet to get into inches, cancel out inches to get into centimeters, cancel out centimeters to end up in meters. And then what I did is I just went ahead and crossed those off. So you'll see here A cancels out, B cancels out because it's top and bottom, C cancels out because it's top and bottom, and we end up with an answer in D. Same thing with feet here. Feet cancels out, inches cancel out, centimeters cancel out, and then we end up with an answer in meters. Now, this is going to be the general type formula, and we'll actually give you these conversion factors. You won't have to know them. You'll see in a couple problems in a little bit. One thing I just wanted to talk about is I always have some kid who's like, couldn't I just convert straight from feet into meters? And the short answer is, no, you can't do that. That's not how this works in this class. The longer answer is, yes, you can. But then you wouldn't learn the skills that we're really trying to teach you. So I'm going to go on a little rant. Feel free to fast forward through this. Here we go. All right, so here's the skill we're trying to teach you. We're trying to eventually get to a part where we're talking about reactions, right? And in this reaction, maybe we're trying to figure out grams of some chemical, right? Here's the chemical reaction that you're going to eventually learn how to create. And these are maybe the 2 compounds that you're working with. And in like an actual chemistry reaction, you'll be given a certain number of one chemical and a certain amount of another chemical in grams. You combine them together and you'll get the products PbI2 and KNO3. Now we're really only interested in PbI2 because that's like our product. That's the one we want. We don't really care about this KNO3. But anyways, maybe we're trying to figure out, yeah, how much of it do we produce? Think about it like in a factory. Maybe they're trying to produce PbI2 as a part of like a shampoo product. So they want to figure out, well, how much of each chemical do I need in order to produce PbI2? That's kind of a real world example, and this is kind of an actual skill that chemists use all the time. Anyways, so here's what you're going to need to do in order to do this. You're going to need to know like 3 different units worth of materials. One of those units worth of materials is this unit right here, so it's important. First thing you're going to need to know is how to balance an equation. That's something that we'll talk about a couple chapters from now. Another thing you'll need to know is you'll need to know this thing called molar mass. And again, that's something we're going to learn next chapter. And then lastly, what you're going to need to know is you're going to need to know how to convert from grams of each of these chemicals into grams of your final chemical. And I'll tell you, the only way to do this, and this is me being 100% honest, the only way to do this is by using dimensional analysis. There's no conversion factor for grams of PbNO32 into grams of PbI2. There's no conversion factor for it. However, there could be a conversion factor from like feet to meters, right? I think it's something like there's like 3.5, 3.25 feet for every meter, right? But there's no ratio of grams PbNO3 to grams PbI2. You would have to actually go from grams to moles, and then you have to find what we call a mole ratio, and then you have to go back from moles to grams. So these 3 steps have to happen. So instead of teaching you this when it's really, really complicated, we're going to start just by teaching you similar types of dimensional analysis, but with easier numbers that you've seen before, like converting feet to inches and then inches to yards or something like that, if that makes sense. Okay, so a couple terms you're going to need to know. First term is dimensional analysis. You can stop rewinding now. Hopefully you have. This is back to notes that you need to know. You're going to want to, dimensional analysis is using ratios to convert from one unit into another type of unit. It's also called a conversion. And then the other term I'm going to use a lot is a conversion factor. It's a ratio. So I put the example of 3 feet divided by 1 yard. So it's just another way of saying a ratio. So anytime you see like a number on top, a number down below in parentheses, that's a conversion factor. That's what we're talking about there. So just to remind you, this is kind of the general process that we're going to follow always. You start off with some unit A, and then you're going to convert it into B, and then you're going to convert it into C, and then you're going to convert it into D. And you do that just by taking A and then putting a new unit on top, and then find another unit that converts to. So like inches or feet, for example, could convert to inches, and it could convert to yards. So you could go from A inches to B feet, and then to C yards, for example. Anyways, here's a problem that I love doing. I used to throw this on the test as like a little extra credit question. This is a problem I thought of back when I was your age, just because I was a nerd like that. I really loved DA back in the day. Still do, realistically. But this is true. If you've ever heard the song Against the Wind by Bob Seger, he claims that he was moving 8 miles a minute for months at a time. So young, 16-year-old me was thinking, what would happen if he moved that fast for an entire month? For example, the month of January. And then, like, as I was figuring it out, I was like, holy cow, he would go around the earth several times. So I went ahead and I did the math. And again, this is just dimensional analysis. I start with 1 unit, I start with a month, and then I can kind of convert from days into hours, into minutes. And then this is the ratio right here of 1 minute is every 8 miles. That's kind of the ratio that he says. And then from there, I can figure out how many laps around the earth he took. What I want you to notice from this is not necessarily that you'll have to do a problem like this, because remember, I told you only 3 steps. 3 steps is kind of the max. What I want you to notice is how every unit that I start with, for example, month, if it's on the top, it then goes down on the bottom to kind of cancel it out. And then days, I start with 1 day on the top, and then days on the bottom. And you'll also notice here that I can say there's 1 month in 31 days, but also 1 day has 24 hours. So this is kind of the step that gets me further along in the process. And then I know hours can relate to days, but it could also relate to minutes. I know that for every 24 hours I have 1 day, but then 1 hour has 60 minutes. And then I can relate minutes back to hours, or I could relate it forward to 8 miles. Bob Seger's traveling 8 miles in every 1 minute, right? And then again, I can relate miles back to minutes based on his speed, or I could relate miles based on the circumference of the Earth. And when you do all that, you figure out it's about 14 laps, but with 1 sig fig, you would round it to 10. Yeah. So anyways, hopefully this problem just goes to show you, again, whatever you start with, you put that same thing on the bottom, and then you put something new on top, and then to cancel it out, you put it on the bottom of the next problem. So I would definitely write down this general process of A goes to B, B goes to C, C goes to D. I would have that written down in your notes. Okay, again, here's the general process. There it is again. Again, just kind of showing you how I would solve it. I would always start with A, whatever unit that is, and immediately put A down below. And then in this red blank here, in this black blank, you're going to start off with whatever number they're starting off. So for example, maybe we're asking you to convert 12 feet into meters. So you'd start with 12 feet here. But then in the red blank here, you would say 1 foot, because 1 foot relates to, I don't know, 12 inches, for example. So B here, you would write the conversion factor. You wouldn't put 12 and 12 here, for example. Then for the next one, B, you would convert into C, and then, C, you'd convert into D. So here's me showing an example with grams, and what are we going into? I don't know, let's figure it out together. Okay, grams. We know that if we're starting with 55 grams, that number would be given in the problem, but the fact that 1,000 grams is the same as 1 kilogram, that would be a conversion factor that we give you. And then the fact that 1 kilogram has 2.01 pounds, this would be another conversion factor that we would give you. And then converting pounds to ounces, oh, that's right. We're trying to figure out ounces here. So hopefully you can see how these three kind of like brackets are each conversion factors that will kind of always be true. The 55 is the number we started with, and that would have been given in a problem. The problem would have said something like, if you have 55 grams, how many ounces is that? And then the other thing the problem would have given you are these three conversion factors right here. And then it would have been your job to kind of take each little bit, like for example, the 1,000 grams, and then figure out, did 1,000 grams go on bottom, or does 1 kilogram go on top? Kind of how do we organize it? And then same thing for the next one and the third one. So you'd have to figure out which order they're in. Does it go 1, 2, 3? And then you'd have to figure out which one goes on top, which one goes on bottom. That's what we're testing you on. And remember, it's always whatever you put, whatever letter you put, whatever unit you put on top, that same unit is going to go on the bottom, so it cancels out. Hopefully that makes sense. Okay, these are all complex forms of 1. It's really just showing you that whatever you put on top, if you put the same thing on bottom, it'll cancel out. So we use that a lot with this right here, where we have units on the top and then units on the bottom. They cancel out. It's all correct math to say that this is, Anyways, here's a problem. This problem is only going to have one conversion factor. It says Thumbelina is a dwarf miniature horse that has officially received the title of world's smallest horse. If she stands at 4.25 hands tall, how many inches tall is she? Hopefully you can see that 1 hand equals 4 inches. That's right on the top here. Here's Thumbelina. If we had this projected on my screen, that would actually be life size. So it's very, very small. 16 inches is like a little bit more than a foot. So tiny, tiny horse. Okay, so for the conversion factor, you'll notice in the problem, 4.25 hands, that's the starting value. That's what we start with. And then 1 hand equals 4 inches. That's our conversion factor. So the first thing we're going to do is we're going to write down 4.25 hands. Then, since our conversion factor is 1 hand to 4 inches, hands go on the bottom, and that's so hands can cancel out here. You'll notice that I showed that in blue. And then for the math, everything on the bottom gets divided, everything on the top gets multiplied. So in this case, we're going to take 4.25, multiply it by 4, divide it by 1, and we get 17 inches. That's our answer. Okay, here's a little bit more of a tricky problem. Here we're talking about a dog. The dog, his name is Maggie, and it lived for 30 human years. So the question is, how many dog years is that? There's Maggie. You might wonder, why is Maggie upside down? That's because she's an Australian cattle dog, right? So we'll flip her right side up for all you Americans over there. Anyways, here's me showing you the process here in order to figure out how many dog years she is old. We took 30 human years, and then we know for every 1 human year, that's the same as 365.25 days. That's one of our conversion factors right there. And then secondly, we know that for every 52 days, that's 1 dog year. That's again our second conversion factor. So what I want you to notice here is how we started in years human, we ended in dog years, and kind of along the way we canceled out human years, we canceled out days, and we ended up in dog years. So yeah, the last thing that I wanted to show you here is that what you're going to want to plug into your calculator. So 30 is the number we start with. That's the first number you'd put in your calculator. Then since 365.25 is on top, we multiply it. 1 is on bottom, so we divide it. Or realistically, anytime you see a lone, just a 1, just leave it alone. You don't have to put ones into your calculator. So 30 times 365, and then 52 is on the bottom, so we divide that number. So if you plug it into your calculator, just like you see here, 30 times 365.25 divided by 52, you'll get this answer of 210. And that's the correct answer. Now, some of you might be thinking, Mr. Smith, I could have just taken 30 and multiplied it by 7, because 1 human year is 7 dog years. Yeah, you could have. You probably could have. But I wanted to get you some practice with two-step dimensional analysis problems. All right. My wife's betta fish, Meryl Streep. It's exactly 4 pellets a day. If a betta's average lifespan is 4 years, each pellet weighs 0.01 grams. How many grams of fish food should Amy buy? That's a great question. There's a little typo there. All right, that typo is fixed. Well, bam. So, a couple things we know. We know 1 year has 365.25 days. We know 1 pellet equals 0.01 grams, and we know 1 kilogram is the same as 1,000 grams. So, that's just a bear. That's Meryl Streep, and this is a picture of Meryl Streep, the betta fish, who's unfortunately passed away, no longer with us. Rest in power, Meryl Streep, the betta fish. So, anyways, the betta's lifespan is 4 years, so that's the number we're starting with. We know that for every 1 year, we have 365.25 days. We know that over the course of 1 day, they consume 4 pellets. So again, notice here how years are canceling out, days are canceling out, and then pellets also cancel out. And then I want you to notice here on the math that I'm taking 4, I'm multiplying it by 365, I'm multiplying it by 4, and then I'm multiplying it by 0.001, and that's going to give me 58.44 grams. And then rounded to 1 sig fig, just because it's 4 years, that is 60 grams. So we ended up getting, since Meryl Streep is no longer with us, we ended up being left with quite a bit of fish food because we bought quite a bit more than 60 grams worth of fish food. Oh well. And then, yeah, just again here, I wanted to show you kind of how I canceled out these units. Remember, any unit you put on top, you have to immediately put on bottom to cancel them out. That's kind of what furthers the problem along. All right. Awesome. So I hope you guys understand this. We'll get a chance to kind of work over some of these problems together. So if you don't understand it right now, that's totally okay. Thanks for tuning in. I hope you guys have a great rest of your day. Take care.